So here's one of our reasonably straightforward patterns that we can try to do a few things with. We can try to come up with an algebraic expression for this pattern. So some kind of an expression where I can calculate any number in this pattern. We can try to figure out, let's say for example, what's the 10th number in that pattern, or what's the 51st number in that pattern. Here are some things that we want to do. We don't necessarily have to do it in this order. The expression I can always do first if I want. The 10th number won't be too hard for us to figure out. What I always suggest that we do in class is create a t-chart and organize the numbers in the pattern. And it helps us visualize what's going on. So I'm always going to start with the term number. That is, well, which number in the pattern is it? Here's the first one. Here's the second one, the third one, and the fourth one. So these are my term numbers. The first, second, third, and fourth numbers in the pattern. The next thing we keep track of is what's the term value. What is the value of each of these numbers in the pattern? Well, the first number in the pattern is 4. So that's the first term value. The value of the second number in the pattern is 7. The value of the third number in the pattern is 10. And the value of the fourth number in the pattern is 13. So the term value is simply the numbers that come up in the pattern that you're given. So here's my chart that I want to start with. To figure out, I'm going to skip over the expression for a second, to figure out the 10th number in the pattern. It's not very difficult for us to just keep going with the pattern and extend the chart. So I could just keep going and do the 5th, 6th, 7th, 8th, 9th, and 10th numbers in the pattern. A lot of kids, when they come into grade 7, are very comfortable to do this. And the only trick here is I have to figure out how the pattern is changing. So by looking at this pattern, the rule would be start at 4, because that's the first number in the pattern, and I'm adding 3 each time. Every time I add 3 to get from one number in the pattern to the next. And it's consistent. That's the pattern. Start at 4, and then I add 3 each time. So this is important to me, that I know what number I begin with and how much it goes up by each time. It's the same amount each time, so that's going to make it easy for us to come up with an expression or to extend the pattern. So not going to be too hard for us to just keep adding 3 here till I get to the 10th number in the pattern. So 13 and 3 is 16. Add 3 more to get 19. Keep going. 22, 25, 28, and 31. So there's the 10th term value. The 10th number in the pattern is 31. A lot of kids are comfortable with doing this. We can identify what the pattern is, what's happening to it, and just extend the chart. Problem is, I don't want to make the chart go to 51. That's a pain. What I want to do is come up with this algebraic expression. Okay. The trick to doing that is looking at how the pattern changes each time. So for my expression, what we've learned in class is that if I notice a pattern goes up by the same number each time, and in this case it goes up by 3 each time, that means that the expression starts with 3n. The n is just this term value. These are the numbers for n. 1, 2, 3, 4, and so on. Which number of the pattern is it? The 3 comes from the fact that I'm adding 3 each time. It's because there are multiples of 3 in this pattern. Okay? So this is the start of my expression. Doesn't mean that it's totally correct yet, but what I want to do is I want to check and see what happens when I put values in for this 1. I'm going to check the first number of the pattern. So what that means is I'm going to check this one. N is going to be equal to 1 here. So I'm going to put a 1 in there. 3n means 3 times 1. And that gives me 3. This is not the first number of the pattern, so it's incorrect. But it gets me a start. What I want to do now is say, what can I do to change this expression a little bit so that I will calculate the right number? Right now I've calculated 3. I want the answer to be 4. So I think all I have to do is add 1. So if I take this 3 and I add 1, I get 4. So that's what I want. It's the first number of the pattern. Well, let's check the second number now. The second n, the second term number, I'm going to use n equals 2. So now my expression is 3 times n plus 1. So 3 times 2 this time, because my n is 2, because term numbers are the n's. 3 times 2 plus 1, because now my expression has this plus 1 on it. I think I need to have that there so it'll calculate all of these numbers correctly. So 3 times 2, that's 6. Add 1, I get 7. Is 7 the second number in the pattern? Yep. Looks good. If I can check the first 3 numbers of the pattern and calculate them correctly, my expression's bang on. So this time, I'm going to use n is 3 because I'm looking for the third number of the pattern. 3 times 3 plus 1. 3 times 3 is 9, plus 1 more. That's 10. 10 is the third number in the pattern. Boom. Now that I've checked all 3 of these, I am very confident, I know for sure, that this expression is correct. I can take any term number, multiply it by 3 and add 1, and I will get the proper term value. This is going to help me so I don't have to extend my chart a ridiculous length. So if I want to do the 51st number of the pattern, this is going to be my n. So if I was to pretend to extend my chart down to 51, what's this number going to be? I don't want to count by 3's until I get to the 51st number in the pattern. I want to just use my expression. 3 times 51, because that's my 51st term number. I'm going to use that for n plus 1. Well, 3 times 51 is 153. Plus 1 more, we have 154. So the 51st number of the pattern is 154. And I did that by coming up with the expression that represents this pattern. I could calculate any number I want now in the pattern. I could calculate the 1003rd number in the pattern if I want. I could calculate the 5 millionth number in the pattern if I want, because I have this expression.